Okay, so logarithms test. The first thing the test is on is just evaluating logarithms. And that's simple and advanced. Now, all of the non-calculator is evaluating logarithms. Obviously, if you have a calculator at this point, you should be able to just calculate it really fast. So the only part that's non-calculator is evaluating logarithms. Everything else has a calculator. Okay? The second part of the test is properties of logarithms. And that's the product property, the quotient property, and the power property. We'll get into that. Again, all of this from here on out is calculator. You have a calculator, but it won't help you out that much, honestly. It will in some parts. The third part of the test is the change of base formula. And that's log of base A of B equals log of B over log of A. And there are two aspects of this. This is like, evaluating logs in your calculator. There's a part that's specifically on that, evaluating logs in your calculator. And the second part of it is the algebraic stuff. So using it. Using the formula algebraically. So evaluating logs in calculators like log base 2 of 17. You wouldn't be able to do that without a calculator, but using the change of base you can. Also, if you've got a fancy calculator, I have no issue with you using your calculator to do it without using the change of base. I have no issue at all with that. It's completely fine with me. So, if you do have a fancier calculator, you kind of have a leg up in that regard, but it is what it is. But with that said, that's only a couple questions. The other questions are using it algebraically, which is log base A of 2 equals log base A of 8 times log base 2 of A. And you guys remember you got to do the change of base and then multiply them and see what cancels and all that kind of stuff. All right? So that's the second part. Or the third part of the test, rather. The fourth part of the test is solving exponential equations. And that's something like 2 to the x equals 8 or whatever it may be. And then the last part is solving logarithmic equations. So that's it. That's the test. So first bit is the first stuff we went through, evaluating logs. Second bit is properties of logarithms. I still have those handouts. You've got handouts for that. Third is the change of base formula. Fourth is solving exponential equations. You're using logs to solve those. And the fifth is solving logarithmic equations. Now, all of these have Khan Academy exercises except for this because you guys got the worksheet for that. If you remember. So that worksheet is what's going to help you for that last one. Any questions before we start just marching through this? All right. So let's begin. The first thing is evaluating logarithms. Okay. Now, it can go from the most simple to the most complex. So the most simple that you could possibly expect would be something like this. Log base 2 of 8. What would that be? 3, yeah. Why? Because 2 to the 3 equals 8. Good. You could also get something like this, log base 2 of 1 over 8. What would that be when it flips it like that? Negative 3. Good. Or it could be log base 8 of 2. And that would be what? Not 3, but 1/3, right? Because 2 is the cube root of 8. Right? And this would be 2 to the negative 3 equals 1 over 2 to the 3 equals 1 over 8. And this would be 8 to the 1/3 equals 2. Because 8 to the 1/3 is the same thing as the cube root of 8, which equals 2. Okay? So, in a sense, those are all simple ones because the answer should be evident just by taking a look at it. Okay? When it becomes more difficult, the last thing would be log base 2 of 1, or log base 8 of 1, let's say. And what would that be? 0. Very good. Why? Because 8 to the 0 is equal to 1. Okay? So those are all the simple ones. And if you don't understand that, you have that exercise that you can do on Khan Academy. You have all those videos. Any questions on any of these? Okay. So these are all the simple ones. But the challenging ones, a little more advanced. So I could say log base 8 of 32. Right? And something like this is a little more challenging. Why? Well, because 8 isn't a root of 32. And 32 obviously isn't a root of 8. So we've got to go with the process. Okay? And how do we do that? This is the process, if you guys remember. We set it equal to x. We end up with 8. We rewrite as an exponential. So the first is set it equal to x. Second part is rewrite in exponential form. And for this you do, remember the whole pinky thumb thing. 8 to the x equals 32. So 8 to the x equals 32. Once you've done that, you find the common root. So what number is a root of both 8 and 32? 2. It wouldn't be 4 because 4 squared would be 16. Guys, in things like this, if you don't have a calculator, honestly, you can assume it's either 2, 3, 4, 5, maybe 6. Because once you start getting up higher, like 6 cubed is a pretty big number. Okay? 8 cubed even is a pretty big is a pretty big number. So, to ask you to do all that multiplication, I could, but that's not what I'm testing you on. What I'm testing you on is this process more than anything else. So you can assume that it's 2, 3, 4, 5, 6, something like that. Maybe it could be higher, but it's probably not. So don't feel like you're stuck because you just can't get it. If you can't figure out a common root, just start with 2. Oh, does 2, 4, 8? Oh yeah. 16, 32. Oh, okay. 2 is a root of 8 and 32. Now, once you've found that common root, you figure out the powers that it needs to be raised to get to each number. So 2 to what is 8? 2 to the third. So 2 to the third to the x power equals 2 to the what is 32? 5. Good. Then I rewrite. It's 2 to the 3x equals 2 to the 5. So I just rewrite. And then if 2 to the 3x equals 2 to the 5, well, it's the same basis, so I equate the exponents. What does that mean? Set the exponents equal to each other. Because the only way for this to be true is if 3x equals 5. Then the last step is solve for x. Divide by 3, I get x equals 5 thirds. So what's the answer here? Log base 8 of 32 is 5 thirds. That's your final answer. Any questions on that? Okay. So you can do any of these logarithms like that. All right, this process is pretty strong, pretty straightforward. You can thank Mrs. McGuire. No, I was doing the most roundabout, it was like all mental, super roundabout way. And Mrs. McGuire tagged me at the end. She was like, just do it this way. She's a great woman. Great teacher. Praise God. All right. Next one. What about log base 9 of 1 over 27? Log base 9 of 1 over 27. Well, I'm going to go through this one pretty quickly because we've already gone through the process. This equals x. Rewrite as an exponent. 9 to the x equals 1 over 27. What's a common root? Now, I don't want to think about 1 over 27. I just want to think about 9 and 27. It's just way easier that way. So what's a common root of 9 and 27? 3. Good. So this would be 3 squared to the x. And this would be 1 over 3 to the third. I promise you, this step going from here to here will confuse you unless you just make it clear in your mind. You're not trying to get rid of this fraction immediately. You're just trying to deal with this number at the bottom. Does that make sense? You're just trying to deal with that number at the bottom of the denominator. Okay? Now I rewrite. This is 3 to the 2x, and now I can get rid of this fraction. This becomes 3 to the what? Negative 3. You see? That two-step process makes it way easier in your mind. Okay? So first you take care of the denominator, and then just make it negative. Now the bases are the same, so I equate the exponents. 2x equals negative 3. Divide by 2. I get x equals negative 3 halves. What was that?
Like where it says 2x over 2 equals negative 3 over 2, is it over 3? And so, like, why is it over 2?
Why am I dividing 2 on both sides? Because I'm solving for x. So would you agree that this is correct here? 3 to the 2x equals, right? So I end up with 2x equals negative 3, right? And then to solve for x, I just have to divide by 2 on both sides. Does that make sense? Okay, good. So I end up with x equals negative 3 halves. Any questions about that? So that's about as tough as it gets, honestly, guys. It doesn't get much harder than that, at least for the purposes that I've taught you. Yeah, you're good. Any questions? Okay. Next, properties of logarithms. So that was evaluating logarithms. Now we go on to properties of logarithms. Properties of logarithms. So, 3 properties of logarithms. First is the product rule. This is that the log of A plus the log of B equals the log of A times B. Guys, these are the ones on the test that you're not going to want to get wrong because they're so simple as long as you understand how to do them. These are the ones you just don't want to get these ones wrong. Because these are your like freebies in a sense. Like as long as you know how to do it, you're good because it's just such a simple process. So what would this look like? It would look like this: log of 3 plus log of 2. And I'd say rewrite it as one logarithm. Let's see exactly. Say rewrite it as one logarithm. Or write it in the form log C, just like it had on Khan Academy. I've literally made it the exact same way, so it's not crazy. You just got to know what you're doing. All right, so I say write it in the form log C. Well, how do you do this? It just becomes log of 3 times 2. Log of 3 times 2 is log of 6. You're done. Now, don't get tricked. The answer is not 6. Right? It's not 6. It's the log of 6. Don't get tricked. It's not log of 5. You're multiplying them. It's not 5. It's the log of 6. It's the log of 6. Okay?
So like in the answers, there's going to be like, it's not going to be, is log going to be included in the answers?
Oh yeah, because you have to. That's the whole thing. Does that?
No, I'm asking like if there's a question like that and then there's the 4 answers, are they just going to be the numbers to where we're going to then?
No. I will say rewrite this in form of log C, and this is the correct answer, so it will have to be one of the answer choices if that was the question. Does that make sense? Yeah. So don't get tricked. The answer is not 6. The answer is not 5. The answer is not log of 5. The answer is log of 6. Okay? The reason why I say this is so simple is because it really cannot get much harder than that. I mean, log 4 plus log 8. Rewrite that. What would that be? Yeah, log of 32. Log of 4 times 8 equals log of 32. That is your answer. That's the answer choice you're looking for, and that's the answer. Yes, sir?
What if it was 8 log 4? Would it be log 32 as well?
No, that's a different property. That's a different property. I'll go into that. Jordan asked, what if it was 8 log 4? And just to address that, this is a different property. This is not log 4 plus log 8, right? This is different. So this becomes the exponent. We're going to get that in a second. This would be log of 4 to the 8th power. Yeah. So that's not what we're covering just yet. Do you guys understand? Here, simple as that. Okay? Now, I will warn you, there are types of questions that I'm not going to cover right now. They're questions that you've never seen before. And I'm not going to show you them right now. Okay? But it's the exact same thing. You just have to be able to see through it and say, oh, it's just the exact same thing, and then just be able to do whatever you need to do. Does that make sense? Okay? So those are the parts of this that is like, oh, a little tricky. It's like, ooh, yeah, I haven't seen one exactly like this before. What do? You apply the concept that you've learned, you apply your understanding, and show me that you actually understand what you're doing. Okay? So don't be scared by that, but just understand that you have to really understand what that is doing. Log of A plus log of B equals log of A times B. Okay? You have to understand that and be able to clarify that in your head. Next is the quotient property. Quotient property is log of A minus log of B equals log of A over B. Okay? What's an example of this? Log of 27 minus log of 9 equals log 27 over 9, which equals log of 3. So when you add, you're multiplying the numbers. When you're subtracting logs, you're dividing the numbers. Again, the answer to this is not 3. It's not 18. It's not log of 18. It's log of 3. Don't get tricked. Any questions on these? All right. Next, just do another example so we're clear. Log of 64 minus log of 4 equals log 64 over 4, which is log of 16. Okay? So whenever you're subtracting logs, you're dividing. And your final answer is log of 16. All right. Now, last one is called the power property. This one is B log A. I always see the word baloney. Bologna. Who calls that baloney? We all do. Where's the E in there? It's Bologna. It's ridiculous. All right. Good job. All right. B log A is equal to log of A to the B and vice versa. This one is a little trickier to deal with because it's just like you're just not used to this kind of thing. But the exponent comes there or the exponent could come back. Doesn't matter. So, for instance, I could have 3 log of 4, and I could rewrite that as log of 4 to the 3rd power, which equals, that will not be an option. You'll have to simplify. 4 times 4 is 16 times 4 is 64. This will be your answer. Okay. Do another one. 5 log 2 equals log of 5 to the 2nd power. Or I'm sorry. See, look, I just made a mistake. It's not 5 to the 2nd, it's 2. This becomes the exponent, 2 to the 5th. Don't make the mistake that I just made. 2, 4, 8, 16, 32. This becomes log of 32. And you're done. Any questions on these? What was that? Okay. Oh. With that being said, you guys know, like, you have like this week and 2 more weeks, and then it's like review week, right? Yeah. You guys are aware of that, right? It's pretty crazy. Pretty crazy. And then I always forget, who are my juniors in this room? 1, 2, 3, 4. You're not. No. I got 4 or 5 in this class. Okay. So it's just we're gonna have little hangout sessions. All right. Shh. Okay. Properties of logarithms. That's properties of logarithms. Change of base rule. Change of base rule. This is log base A of B equals the log of B over the log of A. Now, the simple stuff is simple. So, like if I have log base 2 of 17, that's just the log of 17 over the log of 2. Okay? Shh. You just do that in your calculator, you're done. No big deal. Okay? Anybody have questions on this kind of thing? Yes, sir. Change of base, sorry. Change of base rule. Every time I say change of base, I think of ace of base. No, it's an old school.
That's what you used to listen to in grade.
The exact. There you go. So the change of base rule, okay, is this. This is how you evaluate logarithms in your calculator. Because what does your calculator assume your base is?
10.
10. Good. All right. Hey, you using your calculator? You okay over there? Guys, phones need to not be out. No phones. Everyone's phones. I spy little phones with my little eye. Need to be not out in the classroom. All right. Shh. We gotta push through these last 15 minutes. Now, what's the hard stuff in change of base rule? The hard stuff is when you get to things like this. Log base A of 27 times log base 3 of A. All right? What does this become? Well, this becomes log of 27 over log of A times, mind you, I'm not going to tell you use the change of base rule. I'm just going to say evaluate. And you have to be able to recognize, oh, this is a change of base rule. Okay, log A over log 3. Bam. Cross them out with vigor. Equals log of 27 over log of 3. Are we done? No. This becomes log of 3, log base 3 of 27. But can I evaluate that? What's log base 3 of 27? 3. Good. Why? Because 3 to the 3 is 27. So your final answer of this whole thing is just 3. Okay? Shh. Isaiah. Thank you. So the whole answer to that whole thing is just 3. Any questions?
But you could just find the log of 27 over the log of 3.
You could in your calculator. Sure. It's fine. Got no issue with that. But it potentially ends up with you making a mistake, in your calculator. So I'd suggest you do it this way. But you can if you want. Okay. Now, what about another one? What about something like this? 1 over log base A of 4. Well, this is the same thing. Now look at me. You don't have to look at me. Look at this carefully. Okay? When you get something like this, this is what I recommend. You immediately turn it into 1 divided by log base A of 4. Why? Well, because this then becomes 1 divided by log of 4 over log of A. But what happens when I divide by a fraction? I multiply by the reciprocal, which is log of A over log of 4. Okay? I get 1 times log of A over log of 4, which just becomes log of A over log of 4. All right? Does that make sense? But am I done? This becomes what? Log base of A. Okay, the base is always on the bottom. All right, so this would be your answer in that case. So you couldn't use your calculator for any of this. Right? You just have to do it algebraically. Okay? Any questions on this? All right. Last one I'll do because I think it's worth it because you guys had some issues with this is, and remember I'm recording this, so if you're not able to get it all down, it's fine. Log base C of 3 over or log base 3 of c over log of c, or something like that. Okay? This, you say it's log base 3 of c divided by log of c, which is the same thing as log of c over log of 3 divided by log of c. But if you got log of c on the top and you're dividing, what happens to it? Cancels. So you're not just left with log of 3 though, you're left with 1 over log of 3, which would be your final answer. Okay? So no matter what, when you've got these fractions, you just divide them and then just take it from there. Any questions? All right.
Wait, why did you get the 1 over log 3 again?
Because the log of c cancels with this log of c because it's being divided, but you're not just left with like 0. It's just 1. All right. Solving exponential equations. All right. Now, I'm going to go straight to the harder ones. 2 times 3 to the x equals 12. Divide by 2. 3 to the x equals 6. Rewrite in logarithm form. This becomes log base 3 of 6 equals x. At that point, what do? Calculator. X just equals, use the change of base, log of 6 over log of 3. And whatever this evaluates to in your calculator is your answer. Okay? So that's solving exponential equations. Okay, let's do another one. Um, 3 times 4 to the 2x equals 18. Okay, in this case, I divide by 3. 4 to the 2x equals 6. Rewrite in logarithmic form. Log base 4 of 6 equals 2x. I am not going to do what Khan Academy did and say, okay, you have the 2 different answers. Remember that? I'm just looking for the answer. Okay? So you just divide by 2. That cancels out. And you're left with x equals log base 4 of 6 over 2, which is, you get log base 4 of 6 is log of 6 over log of 4 using the change of base, and then you just divide your answer by 2. Okay? If that looks confusing to you, it's just because it's a fraction within a fraction. But honestly, you just do this part first and then divide your answer by 2. Okay? If you are having trouble with that, you got to go check out solving exponential equations using logarithms. Yes, yes. Guys, you know, for those of you going into college algebra, which might be a few juniors, you got until the 20th. Is that right?
Yep.
Do you want to make a quick announcement about that? I'll give you a couple minutes, or that's pretty much it, right?
Pretty much it. If,
All right.
I don't want to give you a class time, but yeah, if you are signing up for the college algebra DE form and also qualifying test, we're the juniors in the room. Me. All right, cool. Qualifying test scores per form is down outside of my office. SAT score. Check your email. They'll send out an email.
Yes.
So test scores are there as far as what you need, and all that's due by Friday. All right.
Cool.
What is the test scores, Mr. Mack?
All right. For SAT, 2 scored, not 3 scored. 2 scored. It's a 24, if I'm not mistaken. 26.5 for math. And for PERT, it is. My paper. PERT is 103 in writing, 106 in reading, 123 in math. SAT 25 reading and 26.5 math. ACT is 17, 19 reading, 21 math.
Wait, what was SAT?
SAT is 2 scores, 25. Reading, 26.5 for math.
When did SAT scores not become hundreds?
Great question. Based on the new score, the new SAT, they have a 3 score, which is what is admission criteria. But for BC, as BC does, they drill down on specifically having the subscales.
Okay, say that math score one more time for SAT.
For SAT, 25 reading, 26.5 math.
Thank you.
Thank you, Dr. Mack.
Where may I put this?
Mrs. Hendrick?
LB, any preference? I'll put it here.
That's fine.
All right, so we good on solving exponentials. Next bit, shh. What about this? What about this? E to the 3x, what? E equals 8. Thank you, sir. That's right. Okay, what do? I divide by 2. I get e to the 3x equals 4. Now, I write in logarithmic form, this would be log base e of 4 equals 3x. But wait a second, isn't there a special name for log base e? ln. So this is just ln of 4 equals 3x. It's actually way easier when it's with e because it's just one button on your calculator. X equals ln of 4 over 3. ln is on your calculator. Make sure you're practicing with your calculator at home. Okay, don't come into the test without practicing because you'll just waste time. Any questions on this? Okay, now the last bit, okay, is also going to be touched. There's only going to be a few questions on this. So don't get super afraid if you can't figure out all the ones on the logarithmic worksheet. But you should be able to do it. It's just we haven't had a whole lot of time to go over this. But if you guys want to pull out your log worksheet, that's a good idea, potentially. Actually, in fact, does someone have one out that I could just take a look at real quick? Do you have yours? Can I remind you? All right. So the easiest ones, guys, the easiest ones is something like this. Log of 4p minus 2 equals log, and this is number 3 on your worksheet, negative 5p plus 5. Okay? And this, the bases are the same, so I just set them equal. 4p minus 2 equals negative 5p plus 5. Okay, add 5p to both sides. I get 9p minus 2 equals 5. Add 2 to both sides. I get 9p equals 7. Divide by 9. I get p equals 7 over 9. Does that make sense? Only thing I have to check is if this one's going to be positive. 7 over 9 is less than 1, so that's going to end up as positive, so I'm good. Remember, the interior of that logarithm, you can't evaluate a logarithm of a 0 or a negative number. Okay, so those are the easiest ones. Next is ones that get a little harder. Log negative m plus 2 equals 4. So let's say log negative m, first I subtract 2 from both sides, equals 2. What's the base of this logarithm if it's not listed? 10, very good. So this becomes 10 squared equals negative m. 100 equals negative m. Divide both sides by negative 1. I end up with m equals negative 100. Okay, now don't get confused. Oh, it's negative, I can't do it. No. Negative 100, but this is negative in there, so that would be the log of positive 100. So that's doable. Does that make sense? Any questions on that? Next, you end up with things like this. log of x, don't pack up just yet, plus log of 7, I got 2 more to do, equals log of 37. Okay? When I have this, I have to do the properties of logarithms. This becomes log of what? 7x equals log of 37. Same base, so I just cancel the logs. 7x equals 37. Divide by 7. And I get x equals 37 over 7. It's positive, so that's good. Last thing is just, I know I'm going fast, ln of negative 3x minus 1 minus ln of 7 equals 2. This becomes ln of negative 3x minus 1 over 7 equals 2. This becomes e to the 2 equals negative 3x minus 1 over 7. Multiply by 7. I get 7e squared equals negative 3x minus 1. Add 1. I get 7e squared plus 1 equals negative 3x divide by negative 3. And I'm done. All right, that's on YouTube. Check it out. So YouTube. Test is tomorrow. Be ready. Be prepared. Be enthused. Thank you, class. Have a nice day.